Good afternoon, this is Ms. Parks, and we are going to be using radian measures to solve arc length and area of a sector. So basically these are portions of a circle that you're going to find. So S stands for arc length. So basically what that means is if you were measuring all the way around the circle, the length, like if you could lay this line down flat and measure the length of this, it would be 2 pi r. Now, if we only want to find a portion of it, right, we only want to find a section of that, then it's called an arc length. Okay, so you're basically finding a piece of the circumference. And circumference is just another word for perimeter of a circle. Okay, theta has to be in radians. Make sure you have a calculator ready because we're going to be doing stuff using your calculator. You can use decimals on these. And we just need to make sure that the radius, or excuse me, that the theta, the angle, is in radians. All right, so formula is that. So S is equal to R theta. They give us, so S is arc length, by the way. So R is the radius is 18.2. And then theta is 3 pi over 8. So to put this in your calculator, you're just going to multiply 18.2 times 3 times pi divided by 8. Run that through your calculator all at once. And the answer is 2.14 centimeters. Okay, so, the radius is in centimeters. Therefore, your circumference or your arc length will also be in centimeters. So again, this has a radius of 18.2. 3 pi over 8 is a little bit less than half, so it's about this much. And we want to be able to find this length right here, and that's considered S. All right, for the next one, S is equal to R theta. So S is equal to the same radius. We're using the same radius throughout the whole thing. 140 theta is 144. However, this is in degrees, and we need to have the angle be in radians. So we just attach a pi over 180 here to make that degrees into radians. We don't even have to reduce that or anything. We're putting it into our calculator all at once and let the calculator do the work for you. So just do 18.2 times 144 times pi, divide by 180, and you should have 45.7 centimeters. All right, go ahead and try the next two on your own, please. Don't forget that if it's in degrees, you must change it into radians. All right, pause the video, and then once you're finished, go ahead and play this. All right, S is equal to R theta. It's always good to write the formula down first. This is 18.2 times 7 pi over 8. When you multiply all that out, you get 50.0 centimeters. Make sure your S and your 5, and that's a lowercase s, by the way, look different. All right, S is equal to R theta. So S is equal to 18.2 times 54 degrees. So to make it radians, that is now in radians. And then just multiply the whole thing out, and you should have 17.2 centimeters for that arc length. So that covers a little bit of arc length. Now let's apply that to this problem here. All right. So latitude gives a measure of a central angle with a vertex at the Earth's center, whose initial side goes through the equator. So let me kind of just draw a picture here so you can kind of see what we're talking about. So if this is the world, okay, and the equator's here, and then we want to know how far north from the equator something is, okay, or how far south something is from the equator, then we're going to use a picture that looks like this, okay? So I would like you to draw a picture when you're doing this. So I know we have a picture there, but we're going to draw one anyway, okay? And it says latitude gives the measure of a central angle with a vertex at Earth's center whose initial side goes through the equator and whose terminal side goes through the given location. So Reno, Nevada is approximately due north of LA. The latitude of Reno is 40 degrees north. So if there was no picture, I would draw this. Equator. So north, you're going to go up. And then this is Reno. Okay? So that's the first thing I would draw. Second sentence. LA is 34 degrees north. So from the equator, LA is 34 degrees north, and Reno is north of LA because they say that here. Now we know that if the whole angle here is 40 and that's 34, that has to be 6 degrees. Okay? The radius of the Earth is 6,400 kilometers, and that will be always the case because that's never going to change. We're still talking about the Earth, so all the Earth equations will use that value. So they want us to find the north-south distance between the two cities. So we will be using this, let me use a different highlighter. We'll be using that little portion right there, and we're going to be finding this, we'll call it S, okay, this part right here, because we want to find the distance between LA and Reno, the length, the arc length. How far are they apart? So we use our arc length formula, which is r theta. So S is equal to r, which is the radius of the Earth, which is 6,400, times theta. The theta we're going to be using is the theta in the highlighted sector because we don't really care about the other part. So it's 6 degrees. We can't use degrees, so we tack on a pi over 180 to make that into radians. All right, and then we multiply this whole thing out, and we get about 670.2 kilometers. And that's it. That's how far apart LA and Reno are. All right? Okay, you guys draw a picture and see if you can figure out the next problem. It is very similar. Once you're finished, go ahead and play. So hopefully you're done with this by the time you're playing this problem. Okay, Pennsylvania is north of Columbia. Nothing to draw yet. The latitude of Erie is 42 degrees north. I'm going to go ahead and draw that. This is the equator. And Erie is about, whoa, that's a terrible arc. About 42 degrees north. All right. Columbia is 34 degrees south. Okay. This is Columbia. So now they want us to find the north-south distance between the two cities. So we're going to find this entire arc length. In order to find that entire arc length, we need to use this sector or this portion of the circle. Remember, this is the Earth. All right. And in order to do that, we need to use that angle. So S is equal to r theta, the radius of the Earth, 6,400 kilometers. The angle that we're using is 42 plus 34, which is 76 degrees, but we need to make that into radians, so we're going to multiply by pi over 180. So now that's in radians. Multiply all that out in your calculator, and you will get 8,489.3 kilometers. which should make sense. All right. Make sure you read when it's north and when it's south. Next part. Give you the formula. We have a rope. That rope is being wound around here by this drum. We have a radius of this. And so how much rope is going to be turned around? So we're going to be using S. So S is equal to R theta. And we have the radius of 0.8725. Remember, R equals radius, not radians. Okay, and then theta equals radians, or angle in radians. Okay, so theta, that should have a degree sign there, is 39.72 degrees, because there's a degree sign here. So we have to multiply by pi over 180 to make it into radians. So when we multiply that out, you get about 0.6 feet. And the reason it isn't in feet is because the radius is in feet. All right, continuing on, in example 4, we have 2 gears here. We have a small and we have a big gear. Now, they're turning at different rates of speed because they have to cover the same area, and this one's smaller. Think of it as like a little kid's bike, right? And these wheels are turning super fast. The bike isn't going very far. But if you have a big beach cruiser, these tires don't have to turn as much to travel the same distance. So the smaller the gear is, the faster it has to turn to cover the same distance as the bigger gear. Okay? So, however, as these are turning right here, they're definitely covering the same distance. They have to be. Think about like a rope going through here or a chain going through here. They're covering the same amount of distance as they go through in the gears. Okay? So, the small arc length has to equal the big arc length. Okay? So each arc length has its own formula, which is R theta. Okay, so for the small one, we have a radius of 2.5. For the big one, we have a radius of 4.8 centimeters. It says if the smaller gear rotates to 225, where obviously as they're turning, the small one is 225. Let me put that down. Then they want to know what this one is. How many degrees? Now, the formula is in pi over 180. We need it to be in radians. I'm going to show you how that's not really going to matter here. And the reason it's not going to matter is because they want the answer to be in degrees. So here's what we're going to do. Because the theta is here, let me go ahead and in order to get to theta, we're going to undo everything else. Okay? So what that means is I'm going to get rid of these. So I'm going to basically multiply by the reciprocal of this. Okay, so I'm going to multiply by 180 over 4.8 pi. And I got to do exactly the same thing to this side. 180 over 4.8 pi. So on the right side, this cancels with this, that cancels with that, and a 180 cancels with 180, so you're left with theta. On this side, pi cancels with pi, 180 cancels with 180. And now the rest of it's left to be done on your calculator. So these two multiply together, divided by that. Okay? So 2.5 times 225 divided by 4.8, and that should give you, and actually this theta, I'm going to put a D here to indicate that that's degrees. Okay? Because that's what we're looking for. If we multiply all this out, we're going to get 117.2 degrees. And it has to be smaller. So if you double check each side, you'll see that they're going to be the same. So if you did 2.5 times 225 times pi over 180, and then you did 4.8 times 117.2 times pi over 180, their arc lengths would come out the same. All right. Go ahead and try classroom example 4. Same process. All right, so small. You should have finished these already. And big, so this is r theta. And then r. And then theta, we're going to go d times pi over 180. I'm going to go ahead and cancel the pi over 180 out on each side because they're just going to cancel out. So that gives me, and then I'll divide both. Well, we're going to get, on this side, these two multiplied together are 540 is equal to 5.4d. So d is equal to 100 degrees. All right. All right. That covers that. So we're going to do, let's do a few more examples here. So now we're going to be doing area of a sector. So let's say that the area of this circle is 400 pi. Then that would mean that each part of these is like 100 pi. So we're talking about area. So area of a sector will be area of just like one piece of a circle, okay? And again, theta must be in radians, and we're going to use this formula here. So area equals r squared theta over 2. So in this problem, we have r squared. I'm just going to put 321 squared times theta, which is 15 degrees. We can't leave it in degrees, so we have to multiply that by pi over 180. And then we're dividing by 2. You can just put divided by 2 here. The 2 and the 180 are both in the denominator. So you just multiply all this out. So 321 squared times 15 times pi. And then you can either divide by 360 or you can divide by 2 and then divide by 180. What you can't do is you can't divide by 2 and then multiply by 180. Okay? So you can do all of this first and then just divide by 360. It's the easiest way to do that. And then you should get 217. No. You should get, 13,488.0 meters squared for this sector. Okay, which is pretty big because that's 321 meters. All right, so you guys go ahead and try the next one. All right, so area is r. You should have already finished this. Squared. Theta, that's in degrees. We need to put it in radians. And then divided by 2. So when you work all this out, you get 217.8 square feet. All right, and we're going to do 3 more problems. And in these 3 problems, they want us to find the measure of each central angle. They want us to find theta. Now, the reason I wrote this is because I want you to be able to kind of understand what this means. Like in radians, if this is 3 and this is 3, that's the definition of a radian. Theta is equal to 1. Okay, that's what the definition is. When the arc length is the same length as the radius, that is the radian. Theta is 1 radian. So in this one, I didn't mean to delete all that. In this one here, if that's 10, then 10 is 1 radian, and the other 10 is a second radian. So here, theta is equal to 2 radians. And here, it's 1 radian. This one, you may not know so easily. So if this is 4, and this part is 4, then that's 1 radian here. And then this is 2. 2 is half of 4. So this is 1.5 radians. But let's do the math, because you can do the math for all of these if you want. So if you do S is equal to R theta, S is this arc length. So that's 3. R is the radius. So that's 3 times theta. So if you divide both sides by 3, you get theta is equal to 1. Okay. Same thing here. S is equal to R theta. So this is S. R is 10 times theta. So if you divide both sides by 10, then theta is equal to 2. So if you do this one, S is equal to R theta. S is the arc length, is equal to R, radius, theta, so we divide both sides by 4, so theta is equal to 1.5 radians. So there'll be questions where you have to do more than one step to get to your answer. So you might have to use this to find the theta, and then you might have to use A equals R squared theta over 2 to find the area. So just know that you have these two formulas at your disposal, and sometimes you need to use both of them to get to the answers. We will practice this in some homework, and that covers section 3.2.